We're going to talk about transportation devices and refueling. Now, all transportation devices need to be refueled. Even a nuclear-powered submarine will deplete its uranium and need to be refueled someday. It's just the duration it takes. But most things, planes, cars, need to be refueled at least once daily if you're using it for that entire day. Or a long duration. Boat could probably last quite a bit longer. Most people don't really think about the different types of fuels, but there's solid fuels, liquid fuels, and gas fuels. And gasoline is not a gas fuel, that's a liquid fuel, but it's very gaseous. Wood, you know about burning wood to make steam. You can also burn wood to gasify it, put it in an internal combustion engine and run it that way. Coal, don't have to explain coal. Nuclear would be considered a solid fuel. The problem with all those fuels is refueling is very difficult if you're dealing with a solid. You can't just have a tube or a wire that pumps the stuff wherever you need it to go. So we try not to use those fuels unless it's for something large. We used to in the past for boats and other things. Wood's not very energy dense. Coal is pretty energy dense. It's also very dirty. Whole nother problem. So what's the easiest to deal with? Liquid gases, because you can pump it around, leave it in a tank, leave it in a bucket. It's pretty easy to deal with, transport, relatively safe. Especially diesel, you can't really set it on fire. So society's kind of landed on these two fuels to power their vehicles. Let's quick talk about diesel versus gas. Diesel is more energy dense, so per gallon you get more energy, more miles, more range, whatever you want to say, than gasoline. But its freezing point, or when it turns to a gel, is much higher. I think it's around 5 degrees. I'm not going to talk about exact numbers. You can research this all you want. But gasoline, its freezing point is a lot lower. So if you have a car that's parked for 3 days and has diesel in it, you might have problems. Now, modern cars and trucks have heaters and tank heaters. And if you're a semi, you're driving all the time, so it's not really a problem. And most of the U.S. or country, world, you don't really see those temperatures, or not for very long. But that's kind of how we settled on gasoline versus diesel. I'm sure there's tons of other reasons. Easier to, well, I should say in the past it was easier to build gasoline engines. They're, gasoline's a cleaner fuel than diesel. All this stuff doesn't really matter. We're going to basically say they're the same thing. Now, I'm not going to explain anything about gasoline, diesel vehicles because everybody knows just about everything there is to know about them. Hydrogen vehicles, those are kind of like compressed air vehicles. Yes, it's possible to make it. Sure, they exist. But it's too expensive. And why is it expensive? Well, you're basically taking water and splitting apart the atoms and making hydrogen and oxygen. And that's how you get your hydrogen. Now, there's other ways to get it. It's a byproduct of when they get natural gas. So there's different ways to get it that are less expensive. But making it takes more energy than the energy used to power any type of vehicle just using electrons. And it's gaseous. It's not a liquid. It's just not a great fuel, but people really love the idea of it. So that one's not going to happen. So then we're back to storing electrons. But we're not actually storing electrons. We're actually storing chemicals in a state that can be converted into electrons. Because pure electron storage would be like a capacitor. We're actually storing energy in chemistry in a battery and then converting that chemistry instantly into electrons to power your car. Talking about electric cars. I think the biggest issues with electric transportation devices, well, aircraft, talking about that, it's simply the batteries are too heavy. They got to make them lighter to go further. If you can't fly more than 20 minutes, it's not super useful. Maybe intercity stuff, flying around the city, VTOL stuff. Sounds great, should work. But cars, you can easily get a car that goes 300 miles, 300 plus for under $20,000. Very, very reasonable. But the way we measure range, I think, is not great. Because people hear 300 miles and they say, well, my car's 400 or 500 and that's less, the number smaller. Me monkey, me want bigger number. And that's not very good for me. But what it actually means is you just have to make more stops when you do long distance travel. The best way to think about range is average speed. So if I'm going to do a 600 mile road trip, it's going to take 8 hours if I drive non-stop in a vehicle. My average speed is going to be 60 miles per hour. That math may not check out, but you get the idea. If I'm driving an electric car, it's going to take 9 hours. Now, most people hear that and say, oh, it's an extra hour, extra 2 hours, whatever it is. First thing to put with that is most of the time, probably half of that, you're going to be stopping to go to the bathroom, grab something to eat, take a walk. Actually, if you take a walk, it's probably the whole time. But just running in, grabbing, going to the bathroom, getting a snack, eating fast food lunch as fast as you can is probably half the time. But let's say you didn't do that. If you just bump up your speed by, I'm not telling you to break any laws or speed, but if you were to bump up your speed 5 miles per hour and hit an average speed of 65 miles per hour instead of 60, you would get there at the same time if you drove nonstop with your stops, driving an EV. And once you think about it that way, it's really not that big of a deal. In fact, if you want to test this, you do a road trip in your gas car or whatever, drive with the cruise set at 60, then drive on the way home set at 65. That's the difference. Now, this only applies to trips that are over 300 miles. A lot of trips for doing, even if it's one way, 300 miles, stop at a hotel, friend's house, charge the car. You don't have to charge on the way home. It's not a big deal. The other thing that nobody really talks about is when you refuel an electric car, you don't have to do anything. So it takes you approximately 20 seconds. 10 seconds to get out, plug it in, 10 seconds to unplug it. The gas car, you got to get out, open up the little tank, put your little nozzle in, get your card out, swipe it, and you're supposed to stand by the pump until the thing's done pumping, and take the nozzle out, put it back. This whole process takes about 7 to 8 minutes. Now, you may only have to do it one time on a trip, but what I'm saying is, in an EV, yes, maybe you have slightly more time that you have to use doing local things like walking around, thinking, eating, or playing on your phone watching this video. Whereas the gas car, you kind of have to stand there. I mean, you can also watch videos while you stand at the gas pump and smoke. I guess smoking's great by the gas pump, right? That's why a lot of people who like electric cars love smoking, because, not a problem. Yeah, so better way to think about it, average speed. And then during the year, If you only take 2 trips, if you only take 2 trips a year. So yeah, specifically to vehicles, gas cars, you drive it around until you run out of fuel. Then you fuel it up, spend 8 minutes fueling it up. Depends on the size of the car and the tank, right? Might be 5 minutes, might be 15 minutes. If you have a station right on your way to work, then the detour is maybe 30 seconds of pulling into the parking lot and pulling out. If you don't have one on your way to work or wherever you normally commute to, then it adds more inconvenience to your life. And you have to plan a little more, pay attention a little more to when you have fuel and don't to get fuel. But when you're going on a long road trip, you just drive till it's empty, spend 15 minutes filled up, not a big deal. Grand scheme of things, refueling a gas or diesel car is not that big a deal, not a problem. Electric car, as long as you have the capability to charge it at home, every day you wake up, you unplug it, takes about 10 seconds, so you spend maybe 20 seconds per day plugging and unplugging your car during normal use. And you don't really think about anything because unless you're going on long road trips, 300 miles is quite a long ways. You don't really worry about your charge or your fuel. When you go on road trips, typical day looks like you wake up 4 a.m., drive for 4 hours, stop, get a snack, charge for 15 minutes, drive to lunchtime, stop, charge for half an hour to an hour, eat lunch, drive till 3 o'clock, get a snack, 15 minutes, drive till 6 p.m., 8 p.m., somewhere in there, get dinner, charge for an hour, and then drive till 1, 2 in the morning. And in a day like that, you could probably drive, depends on road speed. Honestly, speed limits affect your range and travel much more. So we're going to say 500 miles to 1,000 miles, depending on speed. But you only do that once a year. And it's really not that big a deal. And if you use self-driving features, I feel a little more comfortable driving an extra hour from midnight to 1 a.m. Gas car, I'm probably going to stop at 11, 12 o'clock. Self-driving car will drive till maybe midnight, 1 a.m. So yeah. There's a couple reasons why electric power will become cheaper than gasoline and diesel over time. Well, it already is, but it'll become even a bigger price disparity between the two. And that is because wind and solar and natural gas are the 3 cheapest energy types of generation. Solar is the cheapest, then wind, then natural gas. Then there's a pretty big margin between that and coal. Coal's kind of in the middle. And then at the very top, the most expensive is diesel and nuclear. There's also hydro, which is a small percentage, and biomass. But that kind of, if you go to, you can find this information online, the cost of electricity and how much it costs. So these cheaper forms of so-called renewable energy, doesn't really matter what it is, the cheaper forms of energy will push the cost of electrons down, which will make the price difference even larger. But right now it's, and there's a big price difference between when you refuel your car, if it's at home or at a supercharger or on the road fast charging an electric car. The price range is anywhere from like 4 cents to 40 cents, so a 10x difference. Gas prices swing, a few bucks, so maybe a 1 or 2x, $1 to $2 to $4, whatever it is, but they're not swinging from $1 to $10. So yes, road trip comparable to gas, but then the rest of the year when you're driving around town, you're talking 5 to 10 times cheaper. So this will drive people to want to do this. And then on the convenience side, even if you do spend more time charging, which on average over a year you will spend actually less time charging a car than refilling a gas car, because you only do it on road trips. At home it takes you about 20 minutes to plug it in, and 20 seconds. Plug it in, and then unplug it. No button pushing. Literally the door opens, you don't have to do anything. You just plug it in, walk away, and don't have to do anything. So for instance, if you're on a road trip and you plug it in, you get out of your car, then you can instantly go eat. You don't have to mess around with a credit card, waiting for it to fuel, and then moving the car. You just leave it, go eat, come back, it's done, and you only really wasted 20 seconds if you're using your time to do other stuff. You can also, whatever. I guess you could watch YouTube while pumping gas, or watch this video. It doesn't really matter. The convenience thing is really not as big a deal as the cost thing. As cost comes down and people are more price sensitive than convenience, that's just an excuse for why people don't want them when they're too expensive.